Hello everybody, my name is Andrei Vinokurtsev, and today I want to present some small presentation on tips and tricks and how you can locate the bugs in streaming system with H264, H265 streaming from the streamer to the client, and you can use it as good recommendation for how to use this and find the bugs in streaming system. Start from what you actually need to know, or what tools you would like to have in your hands before you starting. First is Wireshark, some reference decoder for H264, much helpful, the same for H265, and it's helpful to have some video analyzer. It doesn't matter commercial or owned, it's just to understand what's the stream based off. And it's worth to understand at least high idea of what is H264 standard, what's the H265 standard, and some sort of RFCs for the H264, H265, and what an actually general idea how the RTP work over UDP between streamer and client. The same idea applies for the RTMP or iOS system or HLS or anything smooth streaming is the same idea. You need to know at least general how actually data come from the streamer to the client. Let's start from the high level diagram, at least from what I'm talking about. First is the streamer on the left side, which actually has the encoder inside and produce a stream. It's streaming to the recording system, which is just recording the media come from here to here, and it stream as well to the client. Client here, it can be software client, hardware client, doesn't matter. We're going to locate the bugs, and it doesn't matter for us currently. Now I want to say it's not transcoding. I'm not going to talk about transcoding problems, and as well I'm not going to talk about audio and video synchronization problem. Then let's simplify everything. Streamer stream to the recorder stream to the client, and streamer stream to the client. It's not transcoding and just video. Now the first, you can already understand the problems. All these three devices can have the problems, like camera or device that's streaming can have encoder problem inside in this box. Second, the camera or device have a streaming issue, and client and viewer can have a receiver issue. This can have a receiver issue, this can have a streamer issue as well. This is a small streamer. If it is in VR and records the stream, then it's actually streaming here as well. Now a communication issue and video decoder specific issue, but we're going to talk about this maybe in next couple of slides, and you will see what I actually mean about video decoder issue. Okay, so let's see some in depth what I mean. Suppose the H264 data compressed come in RTP format, and it can come in an XB format, but it's packed in RTP. Then it's actually, let's start from here. Now we want to create an XB format without RTP data, because at the end we want to push this data to FFmpeg decoder. It's worth to have some verifier, at least understand that ANXB format isn't broken. At least it's not completely non-ANXB format before you push to FFmpeg decoder, because FFmpeg decoder have some geo resilience code that will not crash immediately, but it can crash it many times if ANXB format isn't good. Now from the FFmpeg decoder we get uncompressed data if everything successfully decoded, and we push this data to video render to see the picture on the screen. Now first we're going to talk today on two blocks, this block and verifier block, and immediately we can see some issues that can arise from here. First is codec specific issue, which we should understand through the standard. Second, when we convert RTP to NXB format, like it's not convert, it's maybe unpack from RTP NXB, and if you push the wrong data to the FFmpeg decoder or any other commercial decoder, it might be decoder specific issue. Now, video render could have the issue if we push the data which could be different size from what we allocated for video render, or it's different length or anything, that the data pushed in video render should be exactly the video render is want to get. And in the case when the dynamic changes coming from the camera or device, like change resolution, it's not specifically on the bitrate because it should have the different bitrate, but resolution, for example, can be very drastically change of the decoder. And network limitation, because if you stream, and today network is 10 meg, but then it's reduced to 1 meg, it's actually or stream reduced or stream is cut off. Then the decoder or all the whole system as a whole should understand how to deal with this problem. Now, this is mostly what I talked about, the issues. It is NXB in hex representation. Now, immediately you can see something wrong here. A lot of zeros packed in the some sort of in between start codes, and it's definitely a problem that should be located. I'm not going to say how to locate the problem, but from taking this you can understand that something wrong in the bit stream that come from the camera or from the device. Now, for example, this example is on the bottom side is 71 start code, which is from the standard, not great, and as well zeros, which is should highlight some problem. And this is exactly what we talked about. We talked about this RTP to NXB conversion. Now let's talk more specifically what the streamer to the client communication, how actually it does work. Suppose we have video encoder on the side of the device, which stream video frame to the streamer. It can be packed in one system, then it can be one box. The streamer sent to the client RTP connection, the messages coming back and forth. They talk to each other, then these messages could be actually broken as well at some point. Now the client produce video frames as well, as we seen with FFmpeg decoder, and sending to the video decoder, which send to the render. Now, and we back to this slide to understand this better than what I actually drawn before is a subsystem of this. Let's see again. This streamer to the client, it's actually streamer to the client or streamer to the client. Now, some tricks that can help you understand the problem. When you're making the Wireshark capturing, you can find then the RTP can come in the packets that could be missing at some point. For example, see, this is a packet 485 for the same source number, but the next packet came as a 494, which is about 9 packet missing. First, it might be not a problem if the packet is very short, but sometimes it could be very big problem if it's happen constantly and the frame actually can be constructed, or the packet can be missing end of frame. Then we will push 2 frames at the same time instead of pushing 1 frame and then second frame. Then this could arise as a big problem, but this can be seen in Wireshark trace by recording here, somewhere here. Okay, let's see what's else. The else is a wrong payload. Suppose this is a payload is a video, and this is payload what it is. Have no idea what it is, but if we're saying that this video and this video and packing it together is one source, we can get to the problem in a few seconds. I will show you what is the problem it can get. You can get to this problem. For example, the payload could be absolutely not the video payload and contain zeros as many as you want, but we packed together to the one video frame and pushed it through the RDP. Then this communication is very crucial. Here is our slide. Sorry, this slide. Then again, this RTP type is not a video. Sorry. Okay, then payload that's not a video, push this video together with a video. It could be delay between packets as well. Like we seen the missing packets, but it could be huge delay between packets. Should see that in the time step as well. And sometimes time steps that camera or device transfer to real time is not representable. Okay, I can't tell about every possible scenario, but I hope it helps you to see more closely what you're actually going to get in streaming system. You can always ask me to this email and follow my presentations. Thank you very much for today. Bye bye.